I'm recording the lecture, so then people can see this later. So, yeah. So let's see, we got that. Let's see, and then is it still? It's still showing up. Okay. Cool. Alrighty, everybody, let's get started. So first, thank you all for coming. I will do what I can to not waste your time. I promise you, if you pay attention during this class, the stuff that you learn here will stick with you basically throughout the rest of engineering school, especially so if you're a mechanical engineer. But literally anything where you're designing anything at all, if you know how to 3D model, that saves so much freaking time. So we'll get this started. On the Google Calendar, it says that this is going to be an hour. I did not schedule that. It will be more than an hour. Right now, my estimate is about an hour and a half or so. Could be a bit longer. There's also some stuff where basically I will let you guys pick what we model. There's some stuff that's a little bit simpler, some stuff that's a little bit more complex. So it's fully up to you all what you guys want to model. So we'll get these slides started and try to go really quick. So first, I'll introduce myself for just a minute, introduce what CAD is, and then I'll talk to you guys about Inventor, and then how to get started in it. And then there's a few different parts that are essential to CAD design. So basically everything revolves around making either sketches, parts with features and everything, assemblies, and then drawings. And then at the end, once we have some parts made, show you how to actually export those to different formats. So things like STL files for 3D printing, DXFs for laser cutting, stuff like that that you guys will be using to take whatever magic model you have on your computer into something in the real world. All in the back, if you want to try to find a chair from one of the nearby rooms and just steal it and bring it in here, you are more than welcome to do that. Or if you want to get extra cuddly and share a seat with somebody, you can try that too. But yeah. So one thing I will say is that coming out of this class, you will not be a professional in CAD, but my goal is to at least give you guys the basic tools and knowledge you need to start making some basic things and then know enough about the situation to where you can then do self-learning later. That's how most of these classes throughout 2 months are going to be. With CAD, there is a lot. There are literally thousands of tools that can be used in all different ways. I'm just going to be showing you some of the basics that are like the most commonly used ones. So the goal is to be able to have you guys come out of here where you're not sitting and wondering, I don't even know what I don't know. Hopefully you'll at least know what you don't know and can investigate it yourself further. So a bit about me. So I did a mechanical engineering degree at a small school called Northwest Nazarene University in Nampa, Idaho. I can pretty much guarantee that nobody here even knows where that is or that it even exists, but it does. One thing that's kind of cool, while I was there, I worked on 5 different space missions that have all been delivered, 3 of them being CubeSats, 2 of them being sounding rocket payloads. And then I'm a graduate student here, unfortunately. And then so I did a master's. I just finished that last year, and I'm about a year away from finishing a PhD in aerospace systems engineering. I help with basically anything spaceflight related at the university. Pretty much anything at this school that's either gone to space or is going to space within recent years of now, I either oversaw or worked on it to some extent. So worked on basically anything ranging from propulsion, payloads, basically the bottom to the top of the rocket, everything in between. And then also, I am the Terminus project manager within the club, and also one of the RCS mentors, and then also the program manager for the spaceflight program within Space Hardware Club. CAD experience. So who here has seen Queen's Gambit on Netflix? Fair bit. Who here has at least heard of it or knows the general premise? Okay, a lot more people. So, some girl kind of gets caught up in like, oh, I'm going to go play chess in like international competitions and stuff. So I did that except for CAD. Like literally I got sent to do like international like CAD competitions like in Russia Like Vladimir Putin was there. Even like it sounds totally stupid, but it is true. I have pictures to prove it. There I am. It's literally it. Who here has heard of like either Skills USA or World Skills or anything? Few people. All right, that's literally how this all happened. So if you're interested, I can talk to you later. But that was a whole other story. So what is computer aided design, or CAD? So CAD is a very, very powerful tool. This lets you very rapidly develop designs that you can then, do some things to it and then eventually either send it to somebody or use it yourself to take your designs from a concept into the real world. So for example, this here is part of a high pressure spray chamber over at the Propulsion Research Center on the south end of campus. Those of you that are new here, if you by any chance have heard any loud booms or explosions or something on campus, or things that sound like gunshots but aren't quite, that's the Propulsion Center. We work on propulsion systems. We've had rocket engines literally explode and crap out and the bottom half falls off the test stand. It's great. But I did some work there. So you can use CAD to make literally anything. So I will say there is a wide variety of different CAD programs out there. There is Solid Edge, which is what the university has used for the last few years. So that's them on the right. But what we're going to be teaching today is specifically Inventor. And then AutoCAD is very, very similar, but more 2D focused. Basically, the user interface is almost the same for the most part. You can use it for different things, but AutoCAD is a little bit more helpful for 2D stuff. So especially anybody that's interested in like civil engineering, or you can also use it very well for things for getting laser cut. I know several projects are going to be involving laser cutting stuff at some point also. Today I'm just going to be talking about Inventor, which is 3D stuff, and you can take things from Inventor and export it to AutoCAD, and same the other way around if you want. Who here is planning on coming to the laser cutting class at some point? Okay, pretty much everybody. I'm teaching that class as well, and I'll teach a little bit of AutoCAD. But if you do this class well, it'll be super easy to transition for you. There's a handful of other programs, so like some of you may have heard of like SolidWorks, Onshape, CATIA, Fusion also. Fusion is another thing by Autodesk. I'll talk about some of these things later, and part of why we're talking about Inventor today instead of Solid Edge. So CAD, you are basically, this is the general process that you follow for making every single part ever, like ever. If you're doing stuff like video game design where you have like biological shapes or something, that is a whole other process. Today we're talking about specifically like technical CAD. This is stuff that you tell somebody to go machine out on a CNC or something like that. So everything here starts with sketches. Everything starts from a sketch at some point. So these are typically, you have some sort of outline, you might have some holes drawn, different things like that. And then what you do is that you take that sketch and then you can apply some feature to it. So like an extrusion or something. So say you make a square outline, then extrude it, you can then make like a rectangular prism or a cube or something like that. You can also do like a revolution where you take it and revolve it around some axis and kind of make like a donut shape or a disc. There's a whole bunch of different features that you can make with sketches. Those features all then combine together. You do feature on a feature on a feature and sketches to produce all of those, and then eventually you have some part in the end. That part you can typically then take to get 3D printed, machined, whatever. You can also use all those parts to then make assemblies. Assemblies are where it's like, all right, I have this thing, and then I have a screw holding in this other piece. It's an assembly. Think of it like Legos. And then drawings can be made from parts and assemblies. Basically, that's where you, if you're wanting to give all of the measurements for a certain part and give it in some concise form that you can give to somebody else, if you did it right, they can look at it and they can replicate your exact geometry from scratch if needed. And then other exports, so talking about other CAD formats for things like printing, milling, laser stuff, all that. Let's see. All right, so now we're going to talk about Inventor. All right, I've been using Inventor for over a decade now, and I absolutely love it. It is my favorite CAD platform, period. So those of you, if you already have touched, who here has touched Fusion 360 before? Okay, decent chunk, y'all. So if you know Fusion, Inventor will be a super nice breeze to just transition over to Inventor. Basically, think of Inventor as its much sexier big brother compared to Fusion. Inventor is also awesome because it is free for students. Autodesk, the company that makes it, they're awesome people. I've worked with them before. I'm literally wearing a freaking Autodesk t-shirt right now. And also, the way that they make all of their software, they make pretty much everything cross-compatible with all of their other programs. Those of you that already went through like the download and install process, if you remember that one window that had a whole bunch of different programs on it, basically anything you make in Inventor can then talk with just about any of those other programs on that web page. So you can do a lot of very powerful things without having to go and do a whole bunch of stupid file conversion or regenerating different things. Also, Inventor, there are loads of resources online for like, tutorials, how to diagnose certain problems, all those different things. A lot more than Solid Edge, which is what the university uses. All right, so the situation why we're doing Inventor instead of Solid Edge. Solid Edge is more like Solid something else that I probably shouldn't say on a recorded video, but that's what UAH has been using for the last few years. As of this summer, they are actively looking for another program to use. And so this is still to be determined. They're looking at like SolidWorks, Inventor, different things, but they haven't come to a decision on that yet. So that's why if any of you are taking the CAD class this year, you're probably going to be learning it in Solid Edge. I am on the side of Inventor because, one, it is free to the university because this university hates spending money. It is an absolute bear trying to get them to do anything. And then one other reason why is because the learning curve for Inventor, from what I can tell, Inventor is the easiest CAD program to start using, but it also doesn't sacrifice high performance stuff. So like most of the spacecraft that I've worked on, all made in Inventor. So you can have very complex things where you have like this for spacecraft it's small, for student stuff it's absolutely huge, like a giant 30-pound drum of all this fancy internal technical whatever the crap, all these different mechanisms doing stuff, all of that made from scratch in Inventor. I also was like the mechanical lead on some of that stuff, but yeah, it's still very nice, easy to learn, high performance. And also, compared to the other options that the university is considering right now, I would consider Inventor the easiest one to learn from and then transfer over to another program. So if you learn how to do all the tools within Inventor, once you know the basic UI and everything, once you know all the basic tools that are at your disposal, you can go to another program and you know what tools you need to do. You just need to find where it is on the screen. They make it very easy to learn. Kind of think of it as like, how some people complain or argue about iPhone versus Android, where iPhone is like very intuitive user interface for the most part. Android, there's a lot more kind of flexibility with things, but it's a little bit easier to get lost on some stuff. Basically, think of Inventor as the stuff that has the really good user interface, but it also still has the same power as like Android type stuff, if that kind of makes sense. So I will also mention you are still free to use whatever CAD program that you prefer. So if a bunch of you already have Solid Edge, or some of you might use like Onshape, SolidWorks, something like that, I will just say, whatever you do, make sure that your entire team is in agreement on whatever program that it is that you're using. This class will be taught in Inventor. If people have questions about things in other programs, I can talk about those after the class so that we save everybody's time here. Inventor is great, and I love it. So if you have not installed it yet, I sent an announcement in the 2-month Discord earlier today. Chances are, if you have not gotten it installed yet, it will not be done downloading by the time we're done here. It is a hefty boy on UAH Wi-Fi. If you do not have it installed already, try to find somebody next to you that you can kind of watch over a little bit, or if you guys want to just kind of tag team, share it a little bit. Really quick, who here does not have Inventor currently running on their computer? Okay, so a few people, but not as much as I was expecting, which is good. So I also will mention that everything that we're doing here tonight will be recorded, and so you can look at it later. Also, I do have some example demo files that are currently on the Canvas page right now. So if you go to the file section on Canvas, go to classes, and then within there's a folder specifically for the CAD stuff. There's a folder that has CAD demo models that you can kind of look at if you want. There's a traffic cone, there's a lightsaber, just a few different things. I literally whipped them up this morning, so they are there if you guys want to look at them later. Also, this class will be taught again tomorrow night also, but it's going to be pretty much the exact same material. So if you're wanting to get more interactive stuff tomorrow, you're welcome to do that. All right, so getting started. So if everybody that has Inventor installed, get it and open it up. So you'll eventually have a page that looks something like this. This picture has 2023. Chances are most of you have 2024. Basically all the same stuff. So it doesn't matter which year you're using. Just I would recommend just get 24 on because it's the newest thing. So yeah, it doesn't have to have pictures. I just pulled this screenshot from the internet. It just has some example stupid files, whatever. So what I will actually do, let's see. So I can show you guys. So I have Inventor open on my computer. This is what it looks like right now. So, yeah. I'll give everybody kind of a minute to get it loaded up because it can take a little bit to start up. And while that's sitting and loading, I'll just explain a few things really quick. So these are just some general things that I'm going to recommend to y'all as you're doing CAD. So with this is completely independent of whatever program you're using. These are just good skills to keep in mind on any program that you're using. So first thing, you want to fully constrain and define all of your geometry. Anytime you make a loop, anytime you make some weird whatever, you do some feature, everything should have a measurement to it. The engineering term is a dimension, basically. Don't think of it as oh, the fourth dimension. Oh, it's none of that stuff. It's measurements, basically. So everything should be fully defined. Basically, if there's any amount of variability where, for example, if you can click and drag a line and still move it, it's missing either a constraint or a dimension or something. And I'll show that a little bit later. Make sure you have everything fully defined because say somebody kind of drags one thing and then somebody else opens it and they don't notice that something got dragged the wrong way and they just keep moving forward. They end up making $1,000 part that now is completely useless because you gave them bad geometry. That has happened. That happens a lot, especially among younger, new people to CAD. Just get it in your heads, fully constrain and define everything. Eventually, if you're wanting to do laser cutting or something at some point, I will go through your designs beforehand, and if there are problems, I will not cut them. I'll let you know what the problems are and then ask you to fix them. But if there's things that are still kind of wonky, not quite done right, I will send it back to you and say, hey, fix such and such things. Same deal will happen with pretty much any manufacturer also that actually has a brain. Another thing, make your features make them correct and easy to understand and modify later. The reason why is because if you try to have everything all in a single feature, it's just super hyper complex, where it can do the equivalent of, like, if you're making a Word document and it's really, really long and you change the size of a picture from like 5 inches to 5.1 inches, it throws off the next 30 pages or something like that. That can happen, or like the CAD equivalent of that can happen if you try to change something later. So take it baby step at a time. Everything is all kind of modular and everything. There's kind of a whole timeline with how, like an ordered sequence with a bunch of these features. You guys will see that later. Just make things easy to modify later. If y'all have heard of KISS, just keep it simple, stupid. So, another thing, this is I'm guessing not, but is anybody here like computer science or software-ish? So, one thing you may have heard at some point is basically if you're repeating any chunk of code, any chunk of a design of something, you're typically doing something wrong and can optimize it. So in here, there's different things like patterns that you can do that, kind of similar to how in code you might have like some sort of a loop or something. Here you can do some sort of a pattern to do something. So then, rather than going and adding features for like 500 holes on some sheet of something that a bunch of screws need to go into, you can just make a pattern and get it done in 30 seconds rather than spending the next 8 hours wanting to die. And so, another thing with making assemblies for things, it can often be better to have multiple smaller and simpler parts rather than trying to combine a bunch of things all into one big file. For example, at my undergrad, there was one group that was wanting to make like a custom drone, like all 3D printed and everything. The very first print that they did, I walked in on it after it was 37 hours in. They decided to print the entire thing all at once. And the only way that they could fit it was they had to fit it in like diagonally all weird, a whole bunch of support material underneath it, one single solid part. It was scary. And then they took it out, wired it up, tried to fly it, lasted all of maybe 5 seconds, then it broke because it crashed. And then rather than having just a simple part that, you reprint it and it's like 20 minutes, now you're looking at another 2 days of print time to print this entire thing. So just remember that. Also, pick a single unit system. Pick either inches or millimeters or centimeters or whatever. Make sure it is something that your entire team is in agreement on what they want to use. I will not judge you if you choose freedom units or communist units, but I will say I do like communist units. They are kind of nice. The magic of the number 10. Just pick something and stick with it. Also, what I would recommend is start with like big and general geometry first, then add all the fine details later. Think of it kind of like if you are an artist, you're drawing a person. Typically, you don't start an entire drawing of a person with just starting on the eyeball or something and then building out from there. Typically, it's like, all right, I have the general form of a torso here. I have some general forms for the arms here, the head, legs, all that stuff. You start with the general shape, and then you add in the details throughout as you go forward. Also, there are multiple ways to do things right. There are several different features and tools that will produce the exact same geometry, but also there are also plenty of ways to do things wrong. As long as your geometry is fine, that's good. But one thing that can sometimes happen is people will have some feature, and then rather than just editing the feature, they're going and adding some additional feature to like cut away at something or change the shape of something. It's like, no, just do it right the first time. It's like think of it like you have something like some block of styrofoam or something, and then you like cut a whole corner off of it or something, and then you're adding like most of a corner left or something and just gluing it back on. It's like, why not just make the cut right the first time or something? Also, to save you a lot of time, let's see. Yeah. So, for example, a lot of the parts that you guys might end up that that was a sentence. Most of the parts that you guys will end up using, so like some of the sensors, pneumatic stuff, body tubes, things like that. A lot of times there is general 3D models out there that you can already use, and I'll talk about some of those different libraries a little bit later. For example, if you're trying to use a Raspberry Pi in your 3D model, are you going to go and model that board with all of the stupid like surface mount components on it, the headers and everything? No, you will want to die. You can just Google Raspberry Pi 3D model on the internet, and you can find a downloadable file that you can then just take, import it, throw it in, good. Saves you hours or days of time on a lot of these things. So anything that you might think is some commercial part, at least do a Google search at some point to see if it already exists. If it doesn't, okay, make it yourself. But for the most part, anything that is of any level of like significant difficulty, chances are some chump out on the internet has already done that for you. So utilize them as best as you can. And one thing that's very, very big that is a huge, huge problem among a lot of very new CAD people is they will make parts that are not manufacturable in the real world. You'll have things that, like, you have some weird, like, underhooked hole in some weird thing. It's like, it's impossible to get a drill bit in there and do things. Think of how these parts that you are making will be designed and assembled in the real world. General rule of thumb, if you cannot conceptualize yourself how you would make it by hand, or like, assuming you know how to use a CNC, you know how to use a 3D printer, something like that. But like, if you can't conceptualize yourself how each feature will be made, you're doing something wrong. Make it in a way that is actually understandable for you, to where you can tell exactly how each feature will be made. I also will say there's a lot of people that are like, oh, I can just 3D print something. I can use support material. I can do whatever. Like, no. 3D printing does not solve all your problems. It solves some, but not all. For example, that 3D printed drone that was just an absolute abomination, like a cubic foot of just support material. It was so bad. So it does not solve all of your problems. So just remember that. Also, so CAD is often done in either an ordered or a synchronous mode. What we'll be teaching today is going to be ordered mode. And what I mean by that is, so if you look on the right, I just have some file open, and you can see on the left there's this little browser looking thing. And down here, there's a little bit more items in it. All those different things, what those are different features and sketches and all these different things that you can start from some kind of general form like this that has some basic geometry defined here. And then you go and keep adding more and more features until eventually you have something a little bit more developed here. Synchronous mode, I'll just say it is a nightmare. We are not even going to be touching that here. Do I have a question over here? Or
what exactly is synchronous mode?
Everything at once. Exactly. It's terrible. I hate it. Yeah. Ordered makes so much more sense. What we can do, if you're making a new file, let's have everybody like start making a new part. So what I'll do, I'll open up Inventor. So you can go to like the new button up in the corner right here. Give it a second. So then you'll be brought to this little window here. This will ask you to start from kind of a default template file. There's you can make either a part, you can make an assembly, you can make a drawing, or you can also make like these are like exploded projections of things where it's like, sometimes you'll see it on like, if you buy new furniture, they'll have some sort of diagram that has all of the parts and then a bunch of holes that trace to where each little screw goes, stuff like that. That's where those come from. I'm not going to talk about those today, but everything else we'll at least touch a little bit. If you see all of these different types right here, what they are is that they're all, or it's like, for example, on, I'll start with the parts right here. So what these are right here, so there's like, you can do sheet metal or there's like standard. Typically, for the most part, I just use standard, like the standard part file. And then if you see like DIN or millimeters, basically it's just different units that you're wanting to use. Also down here, if you see like some of these like assemblies and drawing things, you'll see like ANSI millimeters, ISO. These are basically different engineering standards. So like ANSI, I don't remember what it is, but it's some American whatever the crap thing. ISO is communist stuff or metric stuff. Like ISO, like units, great. The style of their drawings, an abomination. I hate it. It's so ugly sometimes. You can also go English stuff. English, obviously, there's not as many options, but same basic stuff. So you've got either standard parts or sheet metal. You've got different types of assemblies. Then you've got drawing stuff, presentation stuff. So for us today, I'm going to use metric units. So so what I can do, I can just pick this right here, just standard millimeters.ipt. So I can just click that, and then it'll bring up an empty thing. Question?
Why are there different file extensions?
The different file extensions, they are, like, are you talking like .ipt? Yep, so .ipt is like inventor part. .iam is inventor assembly, basically. .idw is like inventor drawing. Just .dwg, that's like just a generic drawing file. Typically, if you're doing something where you're also talking with another program, so like AutoCAD or something, you could use that. And then .ipn is for like inventor presentation, basically. So you can look at a file extension and know exactly if it is a part, an assembly, drawing, different stuff like that. Most other CAD programs, they have their own set of extensions. So like SolidWorks has like .solid part, basically, .solid assembly or whatever. Pretty much they all have their own fancy proprietary file type that runs in some mysterious Minecraft enchanting table language, something like that. So here we have a thing open, and I'm going to go back to the slides for just a minute and explain a few other things really quick. So you'll have these different options right here. You can just pick whatever type of file you want to work with. Everything that we're going to be talking about today is we're going to be making parts, assemblies, and drawings. And as I mentioned, you can use basically anything that you'll use in like engineering school stuff. You're going to be using either ANSI or ISO standards. Those are pretty much the only two. The user interface. This is a little bit outdated version, but the general layout is still for the most part the same. So we've got different toolbars and things all around. I'll show how that looks around here. So up at the top you have some different toolbars, ribbons, and everything. Basically, everything that you're going to be doing, all of your tools to make everything are all going to be up at the top here. Just think of it like Microsoft Word. All of your tools to modify and change text and things are all up there. On the left, we have the browser. So this is where eventually we're going to be able to have all of our different sketches and features and everything all listed here. When we're in an assembly, we'll then have basically all of our parts loaded in here. If we're making a drawing, we're basically going to have a browser that has basically each page of the document that we're making. On the right here is a few different navigation tools. So one thing I'm going to do, I'm going to just turn something on really quick. And I'll explain it later. But there's this little cube in the top right here. This will be your best friend when you're trying to orient things around. So you can literally just, the different arrows or the different parts of the cube, you can click it and it'll change your orientation or your view around everything. If you click on it and drag, like hold and drag, you can also just kind of drag the cube around into whatever orientation you want. There's also a few different options. So like there's this button right here. This is the orbit button. Basically, you can use this to kind of do the same thing. You can kind of click and drag, do whatever. There's also like the pan button right here, this little hand on the right. You can pan basically side to side, however. There's a few different things here. Those are kind of the main few that we're going to talk about. And then there's also this home button in the top left that's right by your cube. That'll bring you to a default orientation every time. You can also redefine that later if you want, but I can talk about that later. For the most part, everything, you can navigate it through here. And then through the rest of the presentation, we're basically going to be going through all of these tools on how to make something. So back to the slides here. One thing I will also talk about, and I'll be able to demonstrate it a little bit later. So for those of you, I'm pretty sure, who here has not used Excel? All right, well, in engineering, you are going to use it a lot. I'll just tell you now. So you know how in Excel you can have like one cell has a function that references a few other numbers or something, does some math, and spits out some number at the end. You can do the exact same thing with Inventor. Most good CAD programs can have some way to do this. So you can have all these different relationships where, like with the click of a single like cell being modified, you can then change a whole bunch of different features and geometry that, you have all these relationships. Like for example, you can have some 4-cylinder engine, you change some parameter, it'll modify all of the parts and the assembly and all of that stuff into like a 6-cylinder engine if you set up your parameters right. This can be very, very powerful if you know how to use it right. Yes, keyword if. And so the way that you can access that, so if you go up to the very top right here, there's this little like f of x button right here. It's called parameters. Here, right now, this file is empty. It has no features, no dimensions, no numbers to it, basically. So right now, it is empty. But, as you start developing a file later on, each dimension that you make will be represented here. And then from there, you can go and start modifying a whole bunch of different things. So yeah, we'll look at that a little bit later once we have something that's a little bit more populated. So here's just an example of like, here's some different dimensions for something, some different numbers. You can assign units. It also tells you where everything is. So here, like for example, this says Sketch 1 right here. If you look over in your browser on the left, you'll be able to find Sketch 1, and you know exactly where this dimension is being used. Same thing all throughout here. So like there's like Sketch 1, Extrusion 1, blah, 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 sketches and extrusions. All these different features can pile on later. One thing I'll also mention is that a lot of like CAD and technical drafting classes will have you start by making some very simple parts that aren't actually useful, such as these. Is anybody in the CAD class right now? One person or two people. Very brave of you. My condolences for having you deal with Solid Edge and its BS. Eventually throughout the class, you'll probably end up making example parts like these or making drawings of them and stuff. I am not a lame old guy that's teaching some horrible CAD program. I'm going to teach you useful stuff and hopefully something that's a little bit more interesting. So I've got kind of two different options for you. One is obviously way more interesting, but it's also slightly more involved. And then as a backup, I also have a much simpler option that we can go with if people don't feel as ambitious or confident in their abilities right now. So one thing we can do, we can make a lightsaber if y'all want. If there's enough interest and ambition, we can basically have everybody in the group right here kind of submit a lightsaber design in a few minutes, and then we'll pick one and we will make it in real time with you. Like, it's not something that I have prepared. Like, I made an example one. So if you want to make an abomination lightsaber that has Girl Boss Baby and Comic Sans on the side of it, we can do that if you guys want. Also, the example CAD lightsaber that's on Canvas is that lightsaber. If you wanted to download it and open it up, you can look at that exact model right now. We can do a lightsaber option. It has a lot of different design freedom options, lots of different features that we can use. And it's a little bit cooler than some useless block like this that you are never going to make, never going to look at again after this class. So we can take something like one of the things on the left or find something on Google, whatever, see what everybody likes, and then make our own, or at least a simplified version of it, because I don't want to be here forever, and I'm sure neither of you or none of you do either, but we can go to whatever level of detail we want, basically. A little bit safer option, if you guys want to stick with something a little bit simpler, we can also do something like a traffic cone. There's different ways to make it, but obviously it's not as fun. It's not as cool looking. Or also, if anybody has any other recommendations on something else other than a lightsaber or a traffic cone, we can do something like that instead if people have suggestions. Basic features and dimensions for the traffic cone. If people are feeling less ambitious and want to try, like if we don't do the traffic cone tonight, if they want to try it later, here's the dimensions. You can make it yourself if you want. So everybody's thoughts. So really quick, who votes for traffic cone? All right, so I'm guessing votes for lightsaber? All right, yep, we're going to do that. All right, so... Yeah. Exactly. And so what we can do is, so the rest of the presentation here, I'm going to go through like how to use all the sketch tools, how to use like all of the different features and part stuff, how to do an assembly, all of the things, but we'll be able to do whatever. So what I'll do, so like, you guys know how like on the radio or something they'll have like different like awards or like contests they'll do. It's like, hey, the 8th caller wins some tickets to some local show or something. So what I want everybody to do is everybody look up some like lightsaber design on Google. Just find some picture, and then what I'm going to ask you to do is in the Discord, like in actually, let me pull up Discord really quick. I'll see if I can make just a temporary channel so we don't spam everybody else with random lightsaber pictures out of nowhere. But let's see. I don't. Okay, so I don't think I can. Yeah. All right. So what we're gonna do? Yes. All right. So what I'm gonna do? So everybody find a picture, and then what I'm gonna do? The 5th picture that gets sent, we're gonna work with that. If it's absolutely horrible, we'll do the 4th one, and then if that one's horrible, the 3rd one, the 2nd, 1st. We'll do something like that. Because like if somebody's trying to pull some like what's it called? Like Count Dooku fancy like curved lightsaber, we're not doing that. Find something simple that everybody could try to do. Yes. I wasn't given the permissions to make another channel, so all right, so we have one right here. Very nice selection. That's not going to happen. So that's 2. 3, 4, 5. Okay, 5. All right, now everybody stop. All right, everybody stop. Everybody stop. Everybody stop. Everybody stop. Everybody stop. All right. I see somebody's typing. Everybody stop. No more pictures. So the one that I saw is 5th. This one. This looks. All right. This looks solid. Easy enough to design really quick. So I'm just going to add a message really quick. Ignore the light. You can cancel it. Yeah. Let's see.
Oh, is Ben Campbell someone important?
Ben Campbell's me.
Oh, my bad.
All good. All right. So, everybody, you can like pull this picture up in another tab or something, have it saved. So what I'm going to do is we are obviously we don't have this in our hands. We're not going to measure it and everything. We're going to kind of eyeball it. So I'll give kind of a quick analysis of how this thing could look like and how we could make this work in the class. So what I see, we can have a section that let's say this brown handle part right here, let's say that's one part. We're just going to call that like the handle, basically. And then we'll have this bottom part, we'll just call that the tail, or something like that. And then the top right here, let's just call that the head. Let's just make it three parts that each have their own features. I'm not going to go to like super crazy detail, but like something that resembles the general form of this. So what we're going to do, so let's start with this handle right here. Let's just make this brown part just a single part right now. So what I'm going to do, I'll explain it. So yep, so if you actually, what I'll do first, I will introduce the tools that we're going to use just for basic sketching stuff before we make the thing. Question.
I have a wild, stupid question. Can you show us how to put it in dark mode? Because it's like
Yes, I will do that. All right. So all good. So everybody that has Inventor open, so what you're going to want to do, you're going to want to go to Tools up here at the top. And then next, what you're going to want to do, you're going to want to go to Application Options, which is right here. You're going to click that. It's going to pull up this window.
Oh boy.
All good. It's literally just a checkbox. So you're going to find a tab on here that says Colors on it. And you'll see something that looks like this. And then you just see this UI theme thing right here. You just pick light or dark. That's all you got to do. There's a few other options that you can play with down here as well, but I'm not going to go into those tonight. You can play with those on your own time. So dark theme, it's here. We'll give, I know it takes like a minute to like load and change everything over, so I'll wait a bit. But what I will do is we'll go to these slides right here, and then I'm going to introduce the basic tools, and then we're going to walk through how we would use them. So the very first thing, anytime you start a new part, you're going to make a sketch. So when you go to hit the like make a new sketch tool, so it'll look, or like start 2D sketch right here, as soon as you click that, what it'll do is it'll pop up this kind of graphic that looks like 3 orange planes in the middle. And then you'll pick one of them, and then that's where you're going to start all of your geometry from. So everything is all just basically centered on the origin. Every plane is like, you know, XY, YZ, XZ, whatever, like the 3 main, like just basic dimensions for things. The next, so once you eventually open up the sketch stuff, you're going to see a tab that, or you're going to see a ribbon that looks like this. And these are all of the basic tools that you're going to be using while you're doing sketches. So we're going to do the lightsaber thing, and I'll talk about the different sections of these really quick. These right here are what you're going to be using to generate all of your line work. So you've got like your line tool right here, circle, arc, rectangle, all of these other things you can use to make different stuff. Most of these also have drop downs with even more options. So like for example, on the line tool, somewhere I'm pretty sure there's like a spline tool. So if you want to make some weird, fancy, obscure curve or something, that's in there. So you can kind of look around some of those different drop downs. Do I see a question over here?
Oh, no, sorry.
Okay. And so there's that. Project geometry, I'll talk about in a little bit. Basically, if you want to reference another feature, rather than redrawing something, you can just kind of duplicate it and it kind of references it. And it's like if you have some fancy outline that you don't want to redo, or you're trying to draw some feature at like a weird angle or something, rather than doing a bunch of like ugly trig or something, you can just say, hey, just copy this edge right here and project it onto this surface or something. You can do that. But I'll explain what that means later. And then you've got these different tools right here, this little modify section right here. So here you've got your basics, like you can move something, copy, rotate, a whole bunch of different things right here. Offset's another very common one. And then here in the pattern section, we can have different types of things. So we can either have like rectangular patterns where it's like, all right, something either going in one direction or two directions, like make a grid. You can also have circular patterns where it's like, say you have some circular thing, like some CANSAT part, and you have a whole bunch of holes going around it. You can use a circular pattern for that. And then there's also the mirror tool. It's like, all right, do all the fancy work or something on one side, and then just mirror it over to the other. So that's a quick rundown of those. Project geometry. Basically, like what I mentioned earlier, rather than redrawing a bunch of geometry, you can just reference something. This is also very helpful, especially if you are going through and modifying something and you have geometry that's referencing something else. So say you have some part, you have a diameter of like a cylindrical section that is, let's say, 6 inches or something. And then you have a series of holes that go kind of around the perimeter of that circle. If you make a sketch that has the positions of all those holes, like to make the second feature, you can try to just reference the circle that's being made so that, and then just add some dimension from that referenced circle that then, say you have the circle and you want to change it to 10 inches diameter or something. That second feature, if you didn't reference it at all, it'll keep all those holes in the same position. It's going to have kind of a cluster of holes in the middle, but not near the edge where you want it. If you use the reference tool or the project geometry tool, you can have that circle be modified as you change that one feature, so then all the holes will also move with it to the outer part as you change the size. Everything else, like you can use project geometry and a bunch of other kind of reference-based features to make modifications for things very, very easy. Very closely tied also with that, like those like function and parameter stuff I mentioned before. It's like Excel functions, basically. Another thing, so this is where all of your constraints are going to be. This is what's going to basically lock your geometry in the right places. This is where you're going to get exact dimensions and measurements for things. So the dimension tool, very basic. It's literally you click a line, you type in a number, gives you the length or something, or it modifies the length for you. Or you pick 2 lines and you pick an angle or something. All of, basic, any kind of number that you can put to put a measurement somewhere, you use that dimension tool. It does everything automatically. Like it'll automatically identify what type of measurement it is that you're trying to make. And then these little things on the side right here, the rest of these are different constraints. So for example, you can have like collinear constraints like this one right here. You can have perpendicular constraints, locking things to be either horizontal or vertical, or there's just this lock button right here. You've got tangent stuff, all of these different types of things. So these can be used that like, it's something that if you're wanting to lock some geometry in place, but you can't really put a number to it, you can put a constraint to it. So basically you want to use any of these that you can't put a number to it. And if for some reason none of these work, this lock button right here just generally locks everything exactly in place. But if you are trying to design something and you're locked into constraining something with just the lock tool, you're probably doing something wrong. So try to see if you can modify your design. Is somebody outside? Let's see. Okay. What was that? Okay. Well, tell them if they want. Oh, okay. Well, you can come in if you want. Oh, okay. So there's some other things that you can do also, like if you want to bring in an image, for example, to use as like a reference, you can do that. Or you can even do like, you can eventually do like decals or stickers on surfaces with an image. And then, you make something, you do a bunch of stuff, and then you're going to hit finish sketch, and then what that'll do, that'll exit you out, and then that'll bring you to another layout that then is like, all right, now we're going to start applying extrusions, revolutions, holes, all of these different things. It'll return you back to 3D mode. All right, so now we're going to make sketch. So we're going to use some of these different tools to make, or at least get started on this lightsaber right now. So what I'm going to do is, so a lot of this, I'm just going to kind of eyeball the numbers, just kind of figure out things in my hand, what kind of feels right, and just kind of make up the dimensions as I go. So if you want to make your own dimensions, you are free to do that. Or if you want to make a whole other lightsaber or something, you can do that. But I will only be answering questions about this here. Question.
So when I scroll, like when I scroll down, it goes out. When I scroll,
Like, are you trying to invert it?
Yeah.
Yeah. It's yeah. You can also Google it. Chances are, just look up like Autodesk Inventor invert scroll wheel, and you'll find some resource that has that. Another question?
How are you starting this? Are you gonna like cut it in the middle, or are you basically starting from the bottom as a circle and extruding it on?
So we'll make it up as we go. But basically, how I'm gonna set this up is I'm gonna have this brown part in the middle, this kind of leathery looking bit. I'm gonna have this be one part, and then this bottom like light metal part is gonna be a second part, and then this upper metal part is gonna be a it's going to be a third one. So what I'll do really quick, let me just go to Paint really quick. So I'm going to,
MS Paint.
yep. Or actually, I can just modify the slides here really quick. So I'm going to do this instead. Let's see. Class 1 lightsaber selection. So I'm just going to put this here, and then, so we're going to have, let's see, one part there. Oh, that is ugly. Let's see. All right. So we're going to break everything up into kind of these main three sections. I'm going to start in the middle with this little leathery bit. So I'm going to close Paint and go to Inventor. All right. So we're here in Inventor. We have a new part. If you haven't opened one already, open up a new part. You can use whatever units you want. I'm going to be using millimeters, though. So right now, everything is all empty. What I'm going to do, I'm going to go up to the top left right here and hit this little button up at the top that says Start 2D Sketch. There's also a drop down that's like, if you want to do a 3D sketch, you can do that. That's a little bit more than what we're going to cover tonight. Start with 2D. That'll be easier. So next, what I'm going to do is I'm going to start on this XZ plane, this flat kind of equator-like plane right now. So I'm going to click that. So now you can see our tools up at the top here have now changed. So we have these different tools here. Looking at this, so how I'm going to kind of make this, I'm going to start just really simply with just a cylinder, basically going from the bottom here up to the top of this brown section. So kind of, I'm just going to kind of ballpark and say like a minimum diameter of, let's say 50 millimeters. So all I did right here, so I just went up to this circle tool right here. I just picked that. And then what I did is that I clicked at the origin. So you should have a little dot in the middle of your screen where this little X, Y axes things are at. So I just made a little thing. Actually, I'll delete this really quick and do it again really quick. So just click a circle, and it'll naturally kind of snap to the middle. I'm going to click it, and then now you can see I have this little text block that's asking, or it's putting in a number. As I stretch it, it gets bigger and smaller. You can see since it's kind of like dark blue highlighted, if I want, I can then just type in a number. So I can have 50, for example, and then it'll automatically do that. If you don't do that, you can also just make a circle, and then you can see it's green right here. And when it's green like that, you can still kind of stretch it, which means this isn't constrained properly. So we need to add some sort of a constraint to actually lock it in somehow. So I can go to like this dimension tool up at the top. I can click that. Then I can click this circle, and then now it's got like a little thing where then I'll click, then it's asking me for a number. Then I'll just put in 50 again. If you're whatever file you're using, whatever the default units for it, you don't need to type in millimeters or anything. It'll just auto complete it for you. If you want to cross into the dark side and use different types of units on the same part, it is possible to do that. The way that you can do that, you have some number, and if you want to use something other than whatever the default units for your file are, you can get rid of the unit extension, and let's say I want it to be 50 inches. I can do that. It's going to be big, but now I have something that is 50 inches in diameter, and it retains that number there, but then you can see here it's 1,270 millimeters. So I'm going to take that back. So I'm just going to delete this inches part, and then hit enter. And then now it reverts back to the default units, which is millimeters. So now we're here. So does everybody know how to make a circle now?
Yeah.
All right. So next what I'm going to do, I'm just going to start this as like the basic feature that we're going to have, and then just kind of add details around it later. So what I'm going to do, I'm going to hit Finish Sketch up in the top right. So now we're here. Let's see this picture again really quick. I'm going to zoom in a little bit. We have that. Okay. So we have a sketch, and we will be reverting back to sketches a lot. One thing I'm going to do is I'm going to preview some of the other like part tools as well, since we're going to start taking this circle and doing things with it. So part design, so we're back here. So the basic tools of everything, so everything, you're going to have tools that look something like this at the top. So on my Inventor window, I have something like this also. Most of your 3D geometry is going to be produced using these different tools. For the most part, like extrude and revolve are like the two most common ones that you're going to use. There's a few others that you can use also. So like there's a sweep. So like you can have some sort of a profile, so like a circle or something, and you can have some other sketch that has some path that you're going to follow. You can make something like a paperclip with this. So you can have some drawing that's a circle, one drawing that's that weird kind of loopy design, and then you can use the sweep tool to basically take that circle and drag it through that path and make a paperclip. There's also the loft tool that you can use that like with the traffic cone thing. So you can basically have a sequence of different shapes that you are then dragging all together to make this kind of stitched thing. Think of it kind of like making like tunnels or something. You can kind of tell by the image right here. So you can have like some square profile and then some circular thing at the top, and basically say, all right, have something that, you know, as you go from the square up to the circle above it, it's changing the geometry as it goes and morphs up to the top of it. So like on the traffic cone, you can have kind of a big circle at the bottom, and then it morphs into a smaller circle at the top. That's one way that you can use that. There's also the coil option, which think of it like if you have, if you're trying to make the fancy 3D model for a screw, you've got a thread that you have kind of imagine like a little triangle section that you're going and swirling it around a bunch of times around a cylinder. Coil tool is for that. You can also use it to make springs and stuff. The emboss tool, this is like if you want to have some sort of outline or text or something kind of projected and cut into the surface or protruding out of the surface. So this can be really good for like, say you have some fancy spherical shape and you're wanting to somehow draw text on it and extrude it. You can use the emboss tool for that. There's a handful of other ones that I won't really go into. There's also holes. So you can basically pick a point and you can pick some standard hole size. So like some metric 3 millimeter hole, it can either be like the clearance hole, it can be a tapped hole, like a tapped hole meaning it has all the threads on the inside. A clearance hole is just something that the screw passes through, but it isn't engaging with it. It can just slide in and out. So you can pick a bunch of different sizes, like based on like standard dimensions with that. There's also the fillet tool, which that's where like, for example, on a phone, pretty much every phone everybody has, no matter what it is, like at the corners, you have these little kind of rounded sections around it, so you don't have a sharp edge that, you know, like pushes against your pocket and can rip a hole in it, or if you like hit your hand hard enough with it, you cut yourself or something. Fillets are good for that. Chamfers are very similar, except just think of it as a flat kind of cut into the corner rather than a round one. There's also like the shell tool, where it's like if you're wanting to hollow something out, rather than having a whole bunch of fancy geometry to go and cut these things out in all different ways, you can just use the shell tool, and it just automatically, like, you pick a thickness that you want the whole part to be, like the whole wall thickness, and then it just hollows everything out in the middle of it. There's also the thread tool. Please don't spend the time 3D modeling the individual threads on every little hole you do. Just use the thread tool. Also, if you're using the hole tool, it also has the thread tool built into it as an option if you want, so then you can just manually, just automatically have a hole that already has all the threads in it. So there's a few different things, and then similar deal over here. There's different patterns that you can use also, very similar to the sketch tools. Some other things that are useful here are these things called work features. These are things like planes, axes, and points. So when you're going and making a sketch for the first time, those 3 orange planes that just pop up, those are planes. You can have basically any sketch that you're making, you want to have that on a plane somewhere. So that can either be like one of these origin planes, it can be like the surface, like the flat surface of some part. You can like, say you have some square and you want to add some feature on the side of it. You just pick the side surface of that square block that you have, and then you can start making a sketch on there and extrude things from it. If you need some other thing that isn't the direct surface of the part, you can make some other feature or use a work feature here that it's an imaginary part that you can use to kind of help structure and order your stuff. So you can either get planes, and so you can have like, say you want to have something kind of stick out a little bit. You can have like a plane that's offset from another plane that you do some sketching over here and then throws to something on the main body. There's also same deal with like axes right here. So you can have just a line that you use as a reference. You can also do points. Most of the time I just use planes. And you can also, you can make planes from axes, you can make axes from points, and then points you can define from like a sketch or some geometry or something. Different stuff like that. It can be just kind of helpful. Yeah. One other thing that you'll start to see is the browser over here. So, for example, this is just some random browser of some random part. If you're sounding shocked right now, don't worry. Like, this will happen automatically. This lightsaber is going to get big. Basically, everything here is all in order. Think of this basically as your timeline of all of your work. So, like I mentioned earlier, where if you're trying to go from the general form of a drawing of a human, you start with like the general shape of the torso, and then you start adding more details later on. Basically, think of that timeline as what is in this browser. So, for example, this extrusion 1, whatever it is, some basic shape. Extrusion 2, some addition to that, some added detail, and just over time, different things all kind of happen. It is also possible to drag and reorder all of these things, but make sure you do things in the right order. Like, so, for example, if you are drawing a person, you can't really just draw the eye first and then, you can't, like, the order kind of matters, basically, if that kind of makes sense. So, one thing that you can also do is with something like this, you can also Those of you that have done any amount of coding before, have you guys heard of like commenting out sections of code where it's not quite deleting it, but you're temporarily disabling it without deleting all of your fancy work? You can do that in here. So what you can have is, I'll kind of show this in Inventor.
Let's see. All right, cool. I just realized my mic died, so that's awesome.
Tomorrow night.
Yeah. So we're there. Let's see. I'm gonna take that off. All right. So next, what I'm gonna do is let's add a little bit of cutaway kind of in some of these, or actually, I'm going to add this kind of bulging section right here. So there's a couple different ways that I can do that. How I'm going to do it today is I'm going to use the revolve tool. So what I'm going to do, so I am here, and what I'm going to do, I'm going to start a new sketch on this XY plane right here. So I'm going to pick that, and then now we're in this view. What I'm going to do now, I'm going to use this project geometry tool right here, and then I'm just going to select this outer surface of the cylinder to then use as a reference. If you use like function F7, you'll be able to basically see a cutaway of the inside of this cylinder if you want. And then if you use function F7 again, it'll just undo that. Or if you have like function lock on, it might be on or off with like just F7. It's not completely needed though, but just showing you that we have some lines at the top and the bottom here. What I'm gonna do is I'm gonna make a line really quick, and I'm gonna pick this bottom corner, and then I'm gonna say go up, let's say 25 millimeters. Something like that, just to give us a little, or actually, I might do a little bit smaller. Just a little bit of gap right here from the bottom right here to the top there. I'm going to do just a bit smaller. Do what? So, yeah, so you can do, you can drag a line and it'll make it automatically, or you can go and hit the dimension tool right here and then pick it. And then it'll let you make a thing. But here, since there's already one here, it recognizes that there's one that already exists and it doesn't let you. And so if you want to change that number, you can just double click it, type in a number, and yeah. Next, what we're going to do, so we have kind of this little like angled section up here, then it goes up a little bit and then angles back down a little bit. So what I'm going to do is I'm going to kind of freehand draw some lines, and then we're going to add some dimensions and constraints to them. So let's pick this and then just kind of go out at a random angle, and then we'll go up a little bit, and you can kind of see how if I'm drawing a line, it'll naturally kind of snap to certain locations. So like if it thinks I'm trying to go vertical, it'll kind of snap vertically. And then if you see this little icon to the left of it, if I move my mouse, it won't show up. But if you see this little icon right here, it's suggesting a constraint already. And if I draw that line while snapped vertically, it'll just add that vertical constraint automatically. Inventor's pretty cool, and it can kind of suggest a lot of things to you to help make the process easier. And it actually does it right most of the time. There's, for example, Solid Edge. Oh, horrible. It is a nightmare dealing with. Yeah, you will learn in time. So, what was that? Just. Did you project geometry? Okay, so there's a lot of things that should be able to snap. Okay, tab now. Tab, you should be able to before you want that one. All right, so we have some things right here. Now I'm going to add some numbers to them, some constraints to them to make them look a little bit more realistic. So what I'm going to say first is I'm just going to assume this angle right here is looking like about a 30-ish degree angle or so from vertical. So what I'm going to do is I'm going to go and hit dimension, and then so I hit dimension, I have this line, which right now is just going to make some length dimension, but what I want to do is an angle. So all I have to do is pick another line. So I do that, and then bam, now I have a thing where it's asking for a number in some way. So I can click and drag wherever I want this to be. So I'm just going to have this in the corner, and let's say 30 degrees. Something like that. So then now I have that, and then let's say I want to know the exact distance from like the outer part of the cylinder to the part that's kind of sticking out. So I can make another dimension, and then now it's identifying that these two things are already parallel and vertical, and so I can just do an offset distance between them. So I can just make a number here, and let's say let's try like 8 millimeters or something, just something simple. And then up here you can see that there's this line right here which can still move kind of up and down. It's not quite nice yet. So next what I'm going to do, let's say from this point right here to this point right here, I want to dimension it. Let's just have it 80, just like that. And then now you can see this line is still green. Does anybody have an idea of what thing it might be missing? What kind of constraint? Or yes, an angle. That is correct. So if I were to take this and kind of drag it, or let's see, if I drag it, I can kind of move and change that angle still. So if I look at this looks like about a 45-degree angle right here. So I'm going to go to dimension. I'm going to hit that line, and then make a 45-degree angle right there. So then there's that. And then one thing that we're going to need is an axis line, and I'll explain what this is in a few minutes. What I'm going to do is I'm just going to go basically to the bottom of this part where it basically snaps green in the middle and just make a vertical line down. So this line, it's not going to be like extruded or done anything, or it's not going to be extruded, it's not going to become like a real part or anything, but I do need that line for something we're going to use in just a bit. If I want, so if you have some line work in your drawing that you don't want to be a part of the actual physical geometry of the thing, but it's helpful for like constructing things, you can select it, and then you can go up to this tool in the top right. So this little thing that looks like a flat red line with an angled part above it, you can basically turn it into what's called a construction line. This is like for basically reference geometry, stuff that isn't real but is useful measurements for things. So I can select that, and then now you can see it's kind of a dotted line. It's a little bit lighter instead. If I want to revert it, I can just select it again, uncheck that option, and then now it's back to a construction line. So I'm going to just hit Control-Z, undo, and then now that is back to being a construction line. So you'll select the line, and then you'll go up to the top right here. There's this little button right here. So there's that. So now we have kind of a profile thing right here, this kind of trapezoid looking shape, and then we have this line in the middle. And then what I'm going to do, I'm going to hit Finish Sketch. Next, does anybody have a guess as to what? Yes, that is correct. So what tool I'm going to use is going to be a revolve. So what I'm going to do is that I'm going to take this trapezoid section, then I'm going to revolve it around this cylinder. So what I'm going to do, I'm going to go to the revolve tool up here. And then, so here it already identified the profile that I want to use. Oftentimes, sometimes if it picks multiple things, you'll want to select or deselect certain things. But right now, that's the only valid loop that it has. But you can see right here, it's got this little red arrow. It's asking for an axis to actually revolve around. It needs to know what is the center thing that it's revolving around. So what I can do, so right now it's asking me to select that. And what I'm going to do is that line that I drew at the bottom, I'm going to click that. And then now it's giving us a preview of what it might look like if we want to revolve it. We can either have the thing go all the way around. We can also type in an angle. Let's say we wanted it to go just 90 degrees. I can just type in 90, revolves 90 degrees. You can also change the directions and do symmetric or asymmetric stuff just like with an extrusion. For this, I'm just going to go all the way around. And then I'm going to hit OK. So now there is that. Any questions up to this point? All right, I'm going to move forward. Next thing, I see that, let's see. So there's this kind of like leather wrapping bit that kind of goes around. I'm not going to go through the process of doing that since the process to do that is a little bit more involved, and in the interest of time, I'm just going to leave it simple and flat right now. But there is still that little silver ring kind of in the middle, so I'm going to add something for that. So what I'm going to do, I'm going to go to Start 2D Sketch, and then go to this plane in the middle right here. So I'm on a sketch with that right now. Next, what I'm going to do is, I'm similar to before, I'm going to use the Project Geometry tool right here to project this circle. So now we have a circle in the middle that I'll kind of visualize how you can change this. So if I go back out of the sketch, and you don't have to do this, I'm just doing a quick visualization. If I wanted to modify the diameter of this cylinder, I can go to this sketch, and right now it's hidden, but that original sketch that I made this whole cylinder from is right there. I can even make it visible if I want. I can right click it and hit visibility, and then now that sketch is there. But I'm gonna undo that, but I can double click on that sketch, and then that brings me back to my beginning where I was before, just temporarily. And let's say I wanted to change this to 30 millimeters, for example. I can change that, hit Finish Sketch, and then now that has updated my part. And since I used Project Geometry when I made that little trapezoidal revolution part down here, it went and scaled everything back down just as I needed it to. And if I go to the sketch that made that, all of the dimensions there are all the same, but everything's all just fine. So I'm going to go back to that sketch and change it back to 50. So now everything's back to the same scale that we were at. And any other feature, if you want to go back and modify it at all in the future, all you got to do is find whatever feature it is that you're wanting to modify, and then you just double click it, and it brings you back to the environment where whatever feature or sketch it was that was made was made. So I'm going to go to this sketch now, which I drew, which was in the middle, but right now it's basically empty. So we have that yellow circle in the middle. What I'm going to do now is I'm going to use this offset tool. So this offset tool, also one thing I'll say, Inventor is really cool where basically you can hover over just about any tool and then it'll pull up a little visual of what the heck the thing actually is. So for example with offset, what we're going to do is so you can select a line and then you can make a line that's just, you know, a duplicate of it that's out a little bit ways that you can define the distance for. So we're going to use the offset tool and offset the circle that's in the middle. And I'm just going to do, let's say, 2 millimeters. Something nice and simple. So then now if I look at the sketch, I have this yellow circle, which is just referencing the basic cylinder itself, and I have this added circle right here that allows me to have now kind of a little channel going around it that I can extrude. So next I'll go to extrude right here, and then I'm going to just select that little ring, and then you can see it's kind of wanting to make a thing already, but I'm going to want to change the numbers and the way it's done. So I'm going to go to symmetric, and then looking at this, that looks like about a centimeter maybe. So let's change that to something like that. All right, let's do that. So then now there is that. Any questions with that little bit so far? Yes.
I'm still stuck on making the trapezoid thing. I don't really understand.
Do you have a partner next to you that can help?
He doesn't understand.
What about, or, awesome. Yeah, if you can help, that would be great. So now we have this, and what I'm going to do is I'm going to turn these planes off really quick so I can just select them either here, so I can basically hit like Control or Shift to select multiple of these planes at once, or I can also just go back to the browser right here and just select them there. And then I'm going to right click. You can right click something here, or you can right click something here. It will give you the same options either way. So I'm going to uncheck this little visibility box. We'll then turn this off. So then now we have a basic shape for the midsection of this lightsaber. Actually, let's add one other feature really quick to this little trapezoid section. Do you see these little kind of rectangle things on the side? How the heck would you draw a rectangle or some boxy thing outside on this little this surface? So I'm going to show you one way that you could do that. So I'm going to go to the part file. This is where we're going to play with some work features a little bit. We're going to basically, there's a whole bunch of different options right here of different planes that you can pick. What I'm going to do is I'm going to hit this one right here, tangent to surface and parallel to plane. What that's meaning is, so if you kind of look at this graphic right here, on this little image, so it's got kind of a block section with kind of a semicircle part on the side. There's a green section, or there's a green face on the left side, and then this curve that's in green, this curved surface, and this little orange square on it. It's basically a new plane that it would be suggesting that is parallel to this surface and tangent to this curved plane. And there's a handful of other options that we can use also, but I'm going to use this one for right now. So I'm going to click that, and then what I'm going to do, I'm going to reference one of these planes really quick as what my parallel plane is going to be. So I'm just going to pick it from the browser, and it makes it temporarily visible. And then next what I can do is that it's asking for what is the tangent curved surface that I'm trying to connect to. So I can click this surface and it'll recognize, hey, here's a curved surface, and it's in this area it's parallel to that plane. So I can click it. Let's see. Oops. What did it do? Let's try that again. That. Okay. So now we have that plane. So if I look at it from the side, this plane is nice and exactly along that curved surface, and it's nice and flat. So now what we can do, if we want to make these little rectangular sections right here, we can hit this sketch tool. We'll make a new sketch on here. So then now, what I'm going to do is, just like in the past, I'm going to hit project geometry in the area that I'm interested. So like this section right here. And then what I'm also going to do, just for simplicity, so it already kind of recognized that the area that we're in, the origin, is basically the middle of this kind of square rectangular surface right here, or this projection of it. So what I'm going to do is I'm just going to make a rectangle from the origin right here. And there's different kinds of rectangles that you can do. Probably by default, the rectangle option that it'll give you is this like kind of corner to corner thing. So you can just kind of drag a rectangle around, however, and you can, you know, move the lines, do all of the things. But there is a quicker way or there's several quicker ways that you can make rectangles of different shapes that keeps you from having to drag and drop a bunch of different things and add constraints. One of my favorites is this one right here, this rectangle with the 2-point center. What that does is that has you pick an origin for the rectangle first, then you drag out the corner, and then it makes a rectangle that's already symmetric around an origin point that you like. So I'm going to select that one. I'm going to go to the origin, and then I'm going to make a rectangle just like this. So right now I'm just going to drag a general shape, something like this. So I don't have any numbers on it, but if I go and try to drag it around, I can do something like that if I want. So I can hit dimension, and I'm going to hit, let's say 40. And let's say this, I want that to be 15. Let's make sure, our origin, you can see, is not fully constrained. So what I'm going to do is let's use some reference geometry. So right now I have it purposefully off center. So I'm going to make some reference geometry, just some basic numbers, and I'm going to show you how to do a little bit of math with it too. So let's say we want the height of this little section. Right here, it's going to give us this little pop-up. It's saying, hey, you can't change this dimension, but it's basically just a reference dimension. If you see this dimension in the parentheses, basically that just means it's referencing something that you can't directly change right here. So it's there, it's grayed out, you can't really modify it. But that means it's being defined by some other geometry. It's a reference dimension. So we have a height right here, and then I'm also going to make a width dimension right here. Same deal right here, can't really change the number right here, but that is the number that we have. Next, what I'm going to do is I'm going to make a dimension from the bottom of this to the middle of this rectangle. And I'm going to go, and right now I'm just going to let it be, and then you can see now that this line right here, if I try to drag it up and down, I can't anymore, because now it's defined here where we have this dimension that determines the height of the rectangle, and then the center of that rectangle is then defined here, which I'm going to modify this in just a little bit. Similarly, I'm going to do a horizontal one, where if I go from basically the side to the side here, and add a dimension right here, I have a number now. So it's off-center, but you can see everything is locked now. So now I just need to define this number and this number properly. So this is where we can start getting into a little bit of the math of things. So one thing really quick, I'm going to hit Finish Sketch. While we're ahead, I'm going to hit Save, because I just realized I have not saved this yet. So I'm going to make just a folder really quick. Let's see. Lightsaber Class 1. I'm going to call this Lightsaber Class 1 Body. I'm just going to call it that for right now. So, saving that. So, if you remember earlier, I mentioned the part that's a little area that's got a bunch of cells that you can type in numbers and things. That little F of X button at the very top. You can see now that as we've been adding geometry, we now have some features. We have some numbers in here. So you can see, by default they just go like, D1, D2, D3, just dimension whatever. And then you can see where that dimension is being used. You can see the units, and then you can see the numbers, like the actual values of them. One way that you can also access things individually, so if we go back to that sketch, so I'm going to just double click the sketch to go back to it, and then there's all of these numbers right here. So let's play with this one right here. This one, we want that to eventually get somewhere right smack in the middle. But you can see right now the number for that, with the way that we defined the angles, it's some ugly number. It's not some clean number. But I want this to be exactly halfway in the middle of this. So I'm going to click this, and so I know that this is dimension 19. And right now I can type in whatever number I want, but one thing I can do, similar to how you can, like if you are typing in a formula in Excel, rather than typing in the individual cell numbers, you can just click a cell in here. You can just click a dimension to reference it. So what I'm going to do, I'm going to hit backspace, just clear that out, and literally I'm just going to select the dimension that I want. I'm going to pick that, and then since I want this in the middle, I'm going to take that number and divide it by 2. So then the height is right in the middle. So I'm just going to hit /2. And you can see when the text turns red right here, that's meaning, hey, you have an incomplete formula. It's not quite right. But then once it turns black, then it's like, okay, that's some valid input that you can put in. So I have this D17, this ugly number right here, divided by 2. And then I can hit the check mark. And now we're perfectly centered. And so if I go back out, and let's say you don't have to do this, but if I wanted to go back and change this dimension right here to like 100 or something, it changes the length of that. If I go back out, you can then see it shifts that rectangle back up. I'm just going to hit Control-Z a couple times really quick and go back to where we want. So now we're here. So then now, how would we go doing a similar process? How would we go about centering it horizontally?
Use that measurement for 66.
So I have this, and then I'll select that, divided by 2, check mark, bam, we are centered. And then you can see everything here. Now if I try to drag and move any of these lines, none of them want to move, which means everything is properly constrained just as we need it to be. So next I'm going to hit Finish Sketch, and I'm going to hit Extrude right now. So now you can see if I make this thing, if I look from the side, you can see that if I do that, it's got this little kind of ugly area on the side that's just kind of a gap area. Question?
How did you center D18? I don't know which one. Like if you were doing something.
Yeah, so all I did was, let's see, this was, or so whatever your vertical or your horizontal dimension is, you can just double click it to where you go to type in a number. And then so for this one, this one is for the vertical centering. So I have this reference dimension right here that I made that's just the dimension of top to bottom of this section. All I did was I just selected it and then typed in divided by 2. And then check mark, yeah. So back to this extrusion bit. If I extrude on this one side, like there's a little bit of like, you know, that kind of an ugly area where it isn't fully connecting. If you try to 3D print this, it will 3D print these two parts or these two solid sections as two different parts, or it'll just print off in the middle of open space and it'll just fall. So we need to actually get this connected properly. So one way that we can do that, we can use the asymmetric extrusion, and we can have some section that comes out a certain distance. So let's say, let's just have this like 1 right now. But then this other one, we need it to go just a little bit further in. So what we're going to do, we're just going to go in until it, you know, enters into the solid. So I'm just going to say 5 millimeters, something just to be safe. So now we're going to hit that. And then if I go back to the home view, now we're here. And then I'm going to right click on this plane and turn it off again really quick. So now we have kind of this cool little rectangular section. It's kind of like this. I'm not going to go and add all of that other stuff, but it is there. So now if I wanted some of these going all the way around, what kind of thing should I try to do?
A pattern?
Yes, correct. So what I'm going to do, so I'm in my 3D view. If I go up to this little area right here, there's this little circular pattern tool right here. You can kind of tell the little icon. It's pretty easy. So I'm going to select that. And then now I have this little feature that I wanted to do. I can pick any features that I want to make a pattern with, but I just have one for right now, so I'm just going to select that. If you want, you can also select things from the browser over here. You can either do it here, or it'll kind of recognize the most recent features in this area and do it automatically. So if I wanted, I could select that revolution too, but since I'm going to be doing a circular pattern, it's not really going to output anything new if I do that revolution, so I'm going to unclick that. So I have that, and then now it's asking for a rotation axis. So now I'm going to click that, and I can pick any kind of circular thing that I want. I'm going to pick this one. So then now it's kind of giving me a preview saying, oh, okay, here's what you might have if you want to have 6 things. So if I look from the top, you can kind of see there's these 6 little regions where we might have new material at. If I wanted to change the number of that, like let's see what this has. Actually, that looks like it has 6, but let's say we wanted it to have 4 for some reason. So here we can change the number of elements in the pattern. So let's say I wanted 4. I can just clear that out, type in 4. So then now I have 4 of those things kind of going around. So then I can also change the angle span that this is active on. So if I wanted this to go around just halfway, I could go 180 degrees, and then now I can see I have 4 things distributed 180 degrees around. But I want 360, and then I'm going to hit OK. So now we have a thing. So we have at least a basic shape that looks something like this. Let's try to make it look a little bit pretty now. So I'm going to hit save again really quick. So let's start adding some colors. So one thing you can do is you can pick a bunch of basic materials. If you go to this top area, the left little drop down, this is going to be specifically for materials. So this is also going to bring in material properties like density or thermal properties, different things like that. That can be used for like simulation stuff. Question?
How would that affect 3D printing?
So this section actually won't affect 3D printing at all. The 3D printing stuff will only need like just the raw geometry.
Okay.
So, but this can be helpful for like if you're doing simulations like finite element analysis, like structural stuff, like seeing how well would this last if you're trying to bend it and it's made of steel versus rubber or something. You can do simulations for that. So let's just say this thing is stainless steel in the middle, but let's say I don't like this color quite exactly like it is. If I go to the right, this will give you an appearance instead. So there's a whole bunch of different kind of appearances that you can pick from. But let's say, let's go to stainless something. Let's say I want stainless polished or something. So I can click that, and it changes the appearance a little bit. But you can also see this changes the whole color of everything. What if I want just a few sections of it to be that? Or let's say I want to change some of these other areas to be brown instead. Actually, what I'll do is I'm going to change all of this to brown and then change some other parts to be that steel color. So I'm going to go here, and then I'm going to find, like, let's find a brown color or something. Let's see. Smooth, dark brown. Let's see what that looks like. Well, it's brown. It looks like a turd, a very technical turd, but it's brown. So you can pick whatever colors you want, but let's say we want this little band in the middle to still be like a steel-looking color, something metallic. If I want to change just a certain surface to be a different color, I can just select that surface, and I can use the shift or the control buttons. Actually, let's see. Does it work for both? Yeah, so you can use the shift or the control buttons to then just pick multiple things. Question?
How did you get the plane to be like right on the edge of the cylinder?
Yeah, so what that was is, so I hit the little drop down for the plane, and then there's a bunch of different options right here. So I used this tangent to surface and parallel to plane option right here. And then what I did was I used this plane right here as like what the parallel part is going to be, and then I can pick a round surface that I want it to be at. So I can do something like that. I'm going to undo that really quick. So to color this little ring, let's pick these 3 surfaces. So when I have those 3 surfaces selected, now what I'm going to do, I can go back to that appearance drop down and pick something else. So let's say I want stainless. I can just start typing in stainless and it'll pull up the section in there. I can then click that material, and then now I have updated that little area. And let's say I want these outer surfaces to also be stainless as well. Let's just do something like that. What was that? Yeah, you can do gold. So let's have these be gold. So we can have that, and then let's just type in gold. What does it come up? Bam. Now they're gold. But yeah, you can pick any colors, material, appearances that you want. If you really want it, you can even make your own things. Are you looking for like kind of like a dark brown metal or something, or like a brass or a bronze maybe? Let's see what that looks like. Let's see what bronze looks like. Ooh, there's a few different bronzes. Let's see what this one looks like. That's kind of dark. Or actually, let's see what copper looks like. Let's see. Copper polished. There's something like that maybe. But anyways, you can change the materials to be whatever. I'm gonna hit save. So next, what I'm gonna do, I'm gonna just let this be done for now. Let's get to assemblies. So assemblies. These are the tools that are needed for assemblies. So what we'll do is we'll make an assembly file soon and start putting this together. And we're not going to make all the parts tonight because that'll take forever. I'm just going to throw in some other basic parts from the other Lightsaber file that you can just kind of use as a reference. So for the most part, pretty much everything that you'll really be dealing with is going to be in here. And for the most part, you're going to be doing like place or constrain for the most part. So place, what that is you'll just pick that and it'll literally just pull up a little file window where it's like, hey, which file do you want to bring in? And then you'll just drop it in. And then this constrain tool right here, what that's going to do is that's going to tell you like, all right, this surface of this part is now in contact with this surface of another part. Or you'll have cylindrical constraints where it's like things are concentric. So like a screw in a hole, for example. And then similarly, you can have patterns, mirrors, and copies and things. You can also, there's the work features right here for other planes and axes and points, just like the previous stuff. There's also this thing, so in the little place tool right here, there's a little drop down and it might show up as like place from content center. So really quick, if I open up another assembly. So let's see, whoops. So this little drop down right here, I can hit either just place, it'll just pull up a little file window, or you can do place from content center. So one thing that's very cool that Inventor has, and a lot of other CAD programs have something similar, is a content center or like a toolbox where it's basically a bunch of different standard parts. There's already models for them. So basic things like screws are in there, nuts. Sometimes it's got like electrical connectors for things. So for example, if we go to fasteners, let's hit this little drop down. Let's find bolts, different kinds of heads. Let's say a socket head. Let's pick something. There's a whole bunch of different things. I can pick any kind of one, and let's just say this one, whatever the crap it is. And it'll ask you to just kind of place it somewhere. I'm just going to hit click, and then you can choose whatever type of standard size you want. So like, let's say I want a 3mm diameter by 10mm length. I can hit apply. And then it changes the size of it. I click it, bam. I now have placed a new screw in here. I'm gonna get out there, get out of there, bam, screw. So that's it's kind of what this section has right here. So you can pick from a whole bunch of different things rather than having to design each little model yourself. Next is constraints. There's a bunch of different kinds, so you can have like either face-to-face constraints. You can have like this button right here is for like angle constraints, where it's like you have a face is some angle away from another face. You have tangent stuff, insertion, mirror constraints, a bunch of different things. So with that, you'll pick one part and a certain part of it, and then you'll pick another feature on another part, and then you can then combine those things into a constraint. So there's that. There's also the planes and axes and points, just like before. And I'll talk about this little design accelerator thing later. So I'm going to get rid of that screw on this file because I don't want to mess up this assembly. But let's save this really quick, and let's go make a new assembly. So let's go to File, New, and then I'm going to pick this standard millimeter.iam file right here. I'm going to have that. So now you can see it's empty. It's got nothing, like my brain. So I'm going to hit place. So I can see. So this is a file that I was, or a folder that I was at before. I'm going to go find wherever it was that this new one is at. I just, it was like standard millimeter.iam. And so now I can just pick whatever things I want. And if I wanted multiple things, I can just drag a whole bunch of things and it'll just dump them all in there. But I've just got the single one right now. So I'm just going to select that and then hit open. So then now I can just kind of drag wherever and then click and then bam. Now I have this little part. So then I can drag this around however I want. So I can have this thing, and then what I'm going to do, I'm going to just place, I'm just going to place some other thing from the other lightsaber part. The what? The cone. This? Oh, actually, sure. Let's do the traffic cone. Let's do something stupid. So we've got a traffic cone. Yeah, so it's a bit big, but let's kind of, we can mount it on the top, something like that.
Can we like put it inside? Like, oh yeah.
Yeah,
On the top. Yeah.
we can do that. So then we've got, so we have this thing, but now it's like, all right, so I can drag it and kind of get it roughly in the same location, but you know, it's never going to be exactly perfectly in the right spot by just kind of dragging it around. Like it's close, and like just looking at it, it looks similar, but it's not, you know, exactly fancy anywhere. So what I'm going to do, I'm going to use some constraints. So what I'm going to do is, so I see that there's a circular section here, and then on top of the cone, there's also this little circular section right here. Let's say I want those perfectly lined up. So what I'm going to do, I'm going to hit this constrain tool, and then oftentimes what will happen is you can select some feature. So like right here, I'm selecting the inner curved surface of the top of the cone, and then I'll select this one right here on the lightsaber part, and then it'll automatically just recognize, hey, you're trying to line these two things up, and then it'll just start and preview that. Bam. So now we're there. If I wanted, I could offset these things to where if I wanted one axis here and say 5 millimeters to the side for the other one, I can add an offset right here. So if I wanted, let's say 20, just something a little bit visually easier to see. So I can offset that however I want. I can do 50 and it'll be off a little bit. But I want this to be concentric, so I'm just going to be 0. So I'm going to hit apply. And then now you can see if I drag this up and down a little bit, it's all lined up still. But if I drag it side to side, it still wants to move, which means there's other constraints that still need to be added. So one other constraint that we can add is some vertical thing. So let's say we wanted, so let's go to constrain, and let's say we want this specific circular edge right here to be lined up with this flat surface right here. So I can just click that, bam, magic. So let's see, whoops, hit something, bam, so we have that now. And then, so now, if I have this, I can move it around still, but they're both combined. So one thing that's a good thing to get in the habit of is anytime you have an assembly and can still drag it around, it's good to constrain it to the origin. And by that, I mean I can pick one of these parts. So let's say the lightsaber one. I can hit the little, I can go to the browser, hit origin, and then I can see these are those three main planes that everything kind of started from at the beginning. Way back like an hour or two ago. So, and then also in the assembly, the assembly has its own origin also. So I can open that up, and it has its own, if I zoom out a little bit, you can see it has its own coordinate system there. So what I'm going to do is I'm going to line up these three planes with these three planes here. So all I'm going to do, I'm going to hit constrain, and then I'm going to hit this plane, and then I'm going to hit this one. Lined up. And so one thing that is important, so if you have a mate constraint, which is like just face-to-face stuff, you can kind of tell right here, you can either have things be either like mated together where it's like the sides of the things are contacting each other. So you can kind of see these arrows coming off these little surfaces of these like blue and yellow parts. You can either have them mated like that, or you can have them basically parallel or flush with each other where it's like if they're side by side, they're both facing the same direction. So here, let's say I want to use the flush constraint. So I just want to make these facing the exact same directions. So I'm going to hit apply. Then I'm going to do the same thing here for these planes. Get those set up. And then same for these right here. Okay, it made a sound. Normally, when you make a constraint, it makes this little click sound. I don't know why it was so loud, though. So then now, we have constraints with the origin and the lightsaber part. And then we have this right here. So let's try to move this lightsaber around. All right, so that's not moving. Now, with what you've seen so far, does anybody have any guesses? So if I try to drag this cone around, will it move at all in any way?
No.
Or
Constrained to the lightsaber.
is it fully constrained?
It's constrained side to side, and it's also up and down, so I don't think there's anywhere it could go.
Could I rotate?
I don't think it could.
There you go. So if I drag this, I haven't constrained it like that yet. So I need at least... So if you have something like a wheel, you can leave that free because like eventually it's going to want to rotate. But let's say in this case we want it stuck. One thing I can do, very similar process to what I did before. I can open up the browser section for the traffic cone, go to the origin, and then I can just make another constraint where I have that plane, then have that lined up with this one. Or if I want to have it flip around the other way, I can use, I can just flip the direction, so then now that little SHC logo is on the other side. So I could do something like that if I wanted, but I'll just do that. So then now everything is perfectly locked, which means we are fully constrained, which means then you can move on to something else if you wanted. So I'm going to hit save on this, and I'm just going to call this abomination assembly.iam. Question?
So you'd have to do that for every part you want stuck together?
Yep. So everything should be fully constrained. if you have like some sort of like joints, so like say you have like a pair of scissors or something that you're 3D modeling, you can have that hinge that kind of goes like that. You can have that loose if you want, or like a wheel. You can have it kind of free rotate on some axle or something. But for the most part, everything should all be constrained. So like especially anything with like flat geometry that's needing to go up against each other. You shouldn't have anything that can just slide around like that. You should have, everything touching, but then also everything that fixes it laterally. And angles and everything. Like, you'll learn once you start seeing a bit more complex assemblies that, you're going to have different constraints. Like, let's see. Here it is. So here, actually, let's try something. So here, let's say I wanted to modify some constraints. Let's say I wanted to have something stick up a little bit, or actually, I'll do it here actually. So here, let's say I wanted to have this kind of stick up off the top a little bit. So I'm going to minimize each of these really quick. So I see there's this part right here, and this part right here. Within each of these, you can see each part then has a series of constraints mentioned underneath it. This is exactly the same as like kind of in the browser section for making a part, how kind of your history of everything is all added there and everything can be modified from there. So all of these constraints are all the constraints that are relevant to this part specifically. And then here we have just 3 constraints here, since it just needs a few things to be defined from this, which then this one is then locked to the middle, or the origin. If I wanted to look at just all of the constraints, I can just hit this relationships option right here, and it goes and opens up everything. So let's say I wanted to, so this one right here I can see is that one that's changing the vertical height. If I just click it by default, sometimes it'll just pick up a number, or let's see. So I can either just type in a number there. So let's say I wanted 20. Bam. Now we have a little bit of separation. I can also just right click on it and hit edit, and then I can go through and change everything here just like I did earlier. So you can do that. And let's say now that you have this thing and you're like, all right, I have this fancy assembly. I want to make some fancy promo picture or like fancy ray traced render and everything. Let's ray trace this abomination. So what we can do, let's go to view. So here there's a few different things that you can do. One thing I'll mention that can be helpful sometimes when assembling things and also with just making a model. You can just go to this view option or this view tab, and there's some different things that'll come up. One thing that can be very helpful is this half section view, or you can drop down and hit whatever thing you want. Let's say I wanted to look down the middle of something, or like pick a plane and cut it off after that point. So I could like pick a surface like this and then do that. And then that lets me just kind of look in the middle or look from some weird angle that I want. And then if I want to get rid of that, I can just hit delete section view, and then now I'm back to normal. So you can do that. Visual style, there's a whole bunch of different options you can do. Like you could do, if you want to make the thing look ugly, you can do that. If you want to have it be like just a wireframe, you can have it look like that. Let's start making it look realistic. So there's some different options right here. So you can have like a ground plane be visible if you want. I typically don't like it. You can have different types of shadows added. So let's add it. Let's add some of those. We can add some reflections on the ground, something like that. And then now, one thing that'll look really cool, you can make it either orthographic or perspective view. So then perspective, it's like, now, then you start getting all the fancy angles and everything. And then, let's see, let's get, there's also different lighting styles. So let's say we wanted to have this in a lab. We can have that sitting on a lab bench. It's like a fake imaginary environment just to look special or something. So let's say we like that, and then you can play with some of these other settings. But then once you're ready, you have some fancy angle. Ray trace that thing. You just hit a little button, and then there's a few different options you can do. So you can either have like really low, like low level stuff that's like way quicker, or if you want to have it just sit and cook for an hour, you can go to high resolution, and then it's going to go just make this fancy stupid thing. I am not going to do that though, but you can do that. And then now we have this little thing, and it'll kind of update, and you can move around whatever angle, and then it'll just update whenever. So you can do that, let it do its thing, and then let's say, so I have this picture now. How do I want to export that as a picture? You just go to File, or so you could screenshot it, but you can go to Export Image, and then you can just pick whatever type you want. If you want to make a TIFF, you can do that. I'm just going to do like a PNG right here. I'm just going to call it that. Hit Save. It'll take a second, and then if I go to the thing, now we have the picture. So you have a picture, but now it's like, okay, well, how do I do anything else useful with it? Here. So let's say, yeah. So let's say we have just like this part right here. We want to export it to a like a 3D printing file. You just go to File, Export, and then you're going to want to hit CAD format right here. And then here you can pick a bunch of different options. So like for 3D printing, you're going to want an STL. Sometimes if you're doing stuff with like video game graphics, like an OBJ will help. Step files are also really good. Step files are universally like accessible by any CAD program, period. So if you have something you're working on and
Wait,
you have
EWJs?
or no steps.
Oh.
Wait, is it universally helpful with solid edge?
Yeah,
That's right.
any CAD program worth even looking at can open a step file. Step files are one of like the most prominent types of CAD files there are. The problem though is that it just opens up your geometry, but it doesn't give you the whole browser thing. Like if you have the browser in Inventor, it's not going to give you a browser in SolidWorks or something. And so that's the thing is, like files in different programs, they all talk different ways. There is currently no supported file type that has browser stuff and is openable by every program with a browser, unfortunately. So you can bring in your basic geometry and you can add new features onto it, but yeah, so you can do that. Design Accelerator probably won't do that right now. Drawings, we'll skip that, but if you want to make fancy drawings, like stuff to hand off to a machinist, these are the tools that you would make. You can play around with, like, if you wanted to go and I'll make a new, like, ISO.IDW. You'll make different things like this, and you can have different, like, basic templates that it'll start with, but, like, I'll just make some default thing. I can be here. I can make some base thing. It pulls up one of my most recently used things. I'll just hit that. You can then do like projections and do different things. Oh, now everybody's all amazed. That's funny. And so like you can do whatever things you want. Let me add. Actually, well, so you can have that. You can go and start just adding dimensions to all the things. I am not doing this right now, but like, for example, if I open up there, I made one for like the traffic cone, which was like the most boring half hour of my life. So like, you can have something like this, and so then you have all of your dimensions, you have section views and everything. You can add notes, you can do different stuff. If you look up tutorials on the internet, you'll find how to do this. And after you've already played a little bit with some of these different tools and everything, it should come fairly naturally. I'm disabling ray tracing on that. Yeah, so there's that. Imports and exports, I kind of talked about that. You can import a lot of a lot of files from different stuff. So like the GrabCAD library will be your best friend. You search anything, it'll be there. So like for example,
GrabCAD.
yeah, Raspberry Pi. Let's see. There's a Pico. It looks like somewhere I was looking on here. There's, bam. There's that. It even has a 3D viewer. Give it a minute. Bam. You can just take that, download that, throw that in your model, rather than dying trying to make this stupid thing.
Who
So-
made that? They must have hated their life.
I have no idea.
A very
Konstantinos Avgeropoulos. Whoever you are, I salute you, man. So then you can see they made the file and they exported it as a step file, which means you can very easily take that and then import it into your model. You can also, if you open if you go to open a file, you can hit this, and there's a whole bunch of different things that technically it can open. Like if you have just native SolidWorks files, you can open them. You just won't be able to see the browser bit. You'll have to make new features to modify them. Or, you know, it's got stuff for CATIA, it has stuff for Solid Edge. You can even open STLs, but yeah. One thing I will mention actually really quick, since pretty much all of you are going to be 3D printing at least something. If you go to export something as an STL, chances are if you just installed everything today, if you go to options, chances are your default STL export settings are going to be like this weird BREP thing. What that's going to be is that's going to be kind of a lower resolution file. If I just hit OK on that and hit save, and then I'm going to actually open up that file. So what it's going to do is that it's going to turn that whole, let's see, I have a bunch of things. Let's see. So I'm actually going to open up that STL. So what it's going to do is, or actually, oh wait, I'm stupid. Let's go to Kira. Give it a second. And so what it does is that lower resolution is going to turn like circular elements like this into kind of polygons, and it might look kind of blocky, and it will show up on your print, and it's not going to look that good. So let's give this a second. So many freaking things. Loading. Okay. So let's then open up that in Cura. Is it open? Oh my gosh.
Alright, see you guys in the morning.
Yep. So you can kind of see. So you see, it's kind of like you can tell it's still an arc, but it's kind of blocky. It's not that great. So what you're going to want to do, you're going to want to make sure that when you export, you're going to hit Options, Resolution, just hit High. You can change these sliders if you really want, but meh, I don't care. I'm just going to hit OK. I'm going to hit Save, and then I'm going to close that. And then here I'm gonna go. So now you can see it's much smoother. So make sure you click that little button. And once you do it once, it'll stay that way for the rest of the time. But yeah. Let's see. Question?
Simulation-wise, is that where we would go into and like simulate if it could like sustain like
Some
crash
load.
impact or like heats and stuff like that?
So you can do that actually natively in here already. So let's say we have this part. If we go over to environments, let's just do some stupid stress analysis. I'm not going to properly constrain it or anything, but let's just go create a study. I'm not going to play with stuff, but let's say just some static load. So I can go and let's say I fix this bottom surface right here. I'm going to hit apply, and then let's put, somebody say a number, a really big stupid number.
1,000 newtons.
1,000 newtons. All right, let's apply that.
I don't know.
Or actually, 15 kilonewtons. Let's do 15. Let's
15.
do some of that.
Stainless steel, let's give it some pressure.
Yeah. So yeah. So then now, let's see what the mesh looks like really quick. I'm gonna change that
So
really
mesh
quick.
shows where it would fold and bend, right?
Yeah, it's the smallest elements that can move around, but you can make that a lot better. So like let's do 0.05. Let's see. 0.05. Let's do that. Update mesh. Give it a second. Okay, it's slightly better. You can go as small as you want. It'll just compute a lot longer. And then let's just hit simulate. Let's hit run. Give it a second. Then bam. And then you can see.
You need to reinforce it more. Use stronger lightsaber.
So
I don't know if you'll ever witness 15,000 newtons.
yeah. But yeah, so like you can do that. You can add torsional loads. You can do whatever. You can even do like if you want to do like modal analysis, like vibration stuff for like a spacecraft structure. I've done that, and it gets all the weird. It'll find all of the resonant frequencies of the thing.
Can you like see the aerodynamics of a traffic cone?
Not with this right now, but what I will show you. Let's see. Inventor, or let's see. Wait, let's see. Or let's see. Somewhere there's Inventor CFD. Where the heck is it?
Still pass it.
Did I? Or
Tolerance analysis?
actually, I think I have it. CFD, yeah. So they have a whole other program specifically for that. So CFD, if you don't know what that stands for, computational fluid dynamics. You see like some NASA, or let's see, I'll just Google it.
Aerodynamics of a lobster.
Exactly. That is exactly what that is. So like this type of stuff, that is all CFD.
But it only does that.
Yeah, but it's like dedicated specifically to that, and it does it well. So you can take an Inventor model and then just open it in that CFD program and then run a simulation on it. And so all of these different things all do different stuff. Let's see. Anyways, there's a handful of other sites that have parts. Anything else? Imports, talked a bit about that. Exports, talked a bit about that. Blah, blah, blah. Laser cutting. DXFs. This I'll probably talk about at the laser class because it is 10 o'clock. Conclusions. Lots of tutorials online. There is a guy on YouTube. He has a channel called Tech 3D. You know how like sometimes you'll find a tutorial for something and it's like some very boring monotone guy in his basement. This guy's from the UK. He has an accent. He has personality. He is actually funny. Yeah, like you will actually stay awake watching his videos, and he has loads of stuff. All right, any other questions on things? All right, cool. Thank you all for coming. Thank you all for sticking around. I know it took a while, but hopefully it's useful. Hopefully you learned something.
Expecting this one to go.
was that?
Did you record that one?
Yes, I did. So I will say there was one section that let's see. There was a section where I did have a mic and then it died. So I have no idea how long it was out for, but the recording, whatever it is, will be up at some point.
I had a lot of trouble understanding any of this.
It'll all be it's all recorded. You can watch it again later, and you can go through the recording, the slides, and then also this guy's channel. Basically, you name it, he has at least like 10 videos on whatever the topic is. There's also, if you want, or let's just look, intro to Autodesk Inventor. I think his stuff would be like the first thing that comes up with some of the first stuff. But like, let's see, there's a handful of different things that can walk through, because I was trying to give like kind of a rushed view showing everything, because like if I just did the bare basics of stuff, it's not going to quite prepare people for the entirety of what all would be needed with the project. So
Rush through, I guess, the end up with me not quite understanding.
do you at least know the things that you don't know?
I don't know, just about everything.
Well, I'll say go through the video, or go through the slides, and that can give you starting points to then like go find tutorials and more example material about the different things. So
Some of this makes me wonder if doing 2 months wasn't a great idea. Cause
it is also possible to do a different do a different part of the work on the project. So like if you want to swap to like electrical or software or something else, because like which challenge are you on?
rocketry.
Rocketry. So